Grammar. What is grammar? Grammar is defined as the rules for forming well structured sentences. While describing the syntactic structure of well formed programs, grammar plays a very essential and important role. In simple words, grammar denotes syntactical rules that are used for conversation in natural languages. The theory of formal languages is not only applicable here, but is also applicable in the fields of computer science, mainly in programming languages and data structures. For example, in the C programming language, the precise grammar rules state how functions are made with the help of lists and statements. Mathematically, a grammar G can be written as a four-tuple N, T, S, and P, where N stands for the set of non-terminal symbols or variables. T or sigma stands for a set of terminal symbols. S stands for the start symbol, where S belongs to N, that is the set of non-terminal symbols. P stands for the production rules for terminals as well as non-terminals. It has the form alpha to beta, where alpha and beta are strings on the union of a set of non-terminal symbols and the set of terminal symbols. And at least one symbol of alpha belongs to the set of non-terminal symbols. Context-free grammar. A context-free grammar, which is in short represented as CFG, is a notation used for describing the languages and its superset of regular grammar, which you can see from the following diagram, where regular grammar is a subset of context-free grammar. Context-free grammar consists of a finite set of grammar rules, having the following four components: the set of non-terminals, the set of terminals, the set of productions, and the set of, or rather, the start symbol. Now let us look at each one of these in detail. First we have the set of non-terminals. It is represented by the letter V, the capital letter V. The non-terminals are syntactic variables that denote the set of strings, which helps in defining the language that is generated with the help of grammar. Set of terminals. The set of terminals is also known as tokens and represented by sigma. Strings are formed with the help of the basic symbols of terminals. Set of productions. It is represented by the capital letter P. The set gives an idea about how the terminals and non-terminals can be combined. Every production consists of the following components: non-terminals, arrow, terminals, or it can be a sequence of terminals. The arrow indicates the next state to which the transition goes forward to. The left side of the production is known as the non-terminals, while the right side of the production is called the terminals. We then have the start symbol. The production begins from the start symbol. It is represented by the symbol capital S. Non-terminal symbols are always designated as a start symbol. Constituency grammar CG. Constitu- Constituency grammar is also known as a phrase structure grammar. It is called constituency grammar as it is based on the constituency relation. It is the opposite of dependency grammar. Before deep diving into the discussion of constituency grammar, let's see some of the fundamental points about constituency grammar, and constituency relation. All of the related frameworks view the sentence structure in terms of constituency relation. To derive the constituency relation, we take the help of subject predicate division of Latin as well as Greek grammar. Here we study the clause structure in terms of noun phrase NP and verb phrase VP. For example, let's take the sentence this tree is illustrating the constituency relation. Now let's take a deep dive into the discussion on constituency grammar. In constituency grammar, the constituents can be any word, group of words, or phrases, and the goal of the constituency grammar is to organize any sentence into its constituents using their properties. To derive these properties, we generally take the help of parts of speech tagging, a noun or a verb phrase identification, and so on. In the diagram present here, we have pictographically represented a sentence S into its constituent NPs and VPs. NP, as we know from the previous slide, stands for noun phrase and VP stands for verb phrase. The noun phrase is further divided into D and N. D relates to the description of where it's happening or descriptor. For example, the word this, the, and so on. The noun phrase N1 stands for the noun tree, N2 stands for relation, and so on. V stands for the verb, where is, illustrating, and so on are verbs. And for example, a constituency grammar can organize any sentence into its three constituents: a subject, a context, and an object. So sentences are consisting of three constituents: subject, context, and an object. These three constituents can take different values, and as a result, they can generate different sentences. For example, if we have the following constituents, then the subjects are the horses, the dogs, they, and so on. Context being are running, are barking, are eating, and objects being in the park, happily, since morning, and so on. These example sentences that we have above can be generated with the help of the constituents present. The dogs are barking in the park. They are eating happily. The horses are running since morning. These are the three sentences formed from the constituents as listed above. Now let's look at another view of constituency grammar, which is to define their grammar in terms of their parts of speech tags. Say a grammar structure containing a determiner, noun, an adjective and a verb, a preposition, determiner, and a noun, which corresponds to the same sentence. The dogs are barking in the park. Another view of this using the parts of speech would be the dogs, which is the demeanor and the noun, Determiner is the main constituent, so the dogs is the determiner and the noun. Let's name it as one, and we associate it with the color red. Then we have the adjective and the verb, which we describe it with the number two. And if from the sentence are barking would be the adjective and the verb. And finally, for preposition, determiner, and noun, you would number it three. And the last part of the sentence, that is in the park, would be categorized into the preposition, determiner, and noun. Now, combining all these three, that is, combining one, two, and three, we get the sentence the dogs are barking in the park. Dependency grammar, DG. It is opposite to the constituency grammar and is based on the dependency relation. Dependency grammar is opposite to the constituency grammar because it lacks phrasal notes. Before deep diving into the discussion of dependency grammar, let's see some fundamental points about dependency grammar and dependency relation. In dependency grammar, the words are connected to each other by directed links. The verb is considered the center of the clause structure. Every other syntactic unit is connected to the verb in terms of a directed link. These syntactic units are called dependencies. For example, let us take the sentence, this tree is illustrating the dependency relation. We have the verb, followed by the noun and subverb. The noun is then further divided into a descriptor, or as we had learned earlier, determiner. And then the subverb is split up into noun phrase, which consists of the determiner, adjective, and the noun phrase itself. The dependency grammar can be thought of as a central element where the surrounding elements are linked with respect to that element. Now let's deep dive into the discussion of dependency grammar. Dependency grammar states that words of a sentence are dependent upon other words of the sentence. For example, in the previous sentence which we discussed, in constituency grammar, barking dog was mentioned and the dog was modified with the help of barking as a dependency adjective modifier, specifying it exists between the two. But this dependency adjective can be changed into a dependency noun if the dog is considered as the central element in the sentence rather than considering barking dog as a whole. Point number two says that it organizes the words of a sentence according to their dependencies. So the structuring of the words in a sentence are changed according to the central element in the sentence. This is this is something we have often done in English grammar in our younger days in school life, where we change and restructure the sentence so that it matches with the central element of the sentence. One of the words in a sentence behaves as a root, and all the words except the word itself are linked directly or indirectly with the root using their dependencies. These dependencies represent relationships among words in a sentence, and dependency grammar are used to infer the structure and semantic dependencies between the words.